In this metal bulb here we have a fixed volume of air, and that fixed volume of air we're going to heat up, and then we're going to measure the pressure that is produced. Now obviously as we heat the air, what's going to happen is that, heat the bulb, the air inside is going to heat up as well, and that means that the individual atoms and molecules are going to be moving faster. So when they collide with the container walls, the metal sphere, they will collide with more force and more often. So we would expect the pressure to increase. So what we're going to do is we're going to heat the metal bulb, and then we're going to use a digital thermometer to measure the temperature. We'll record the pressure that is produced, and from that we'll be able to analyze the results. The easiest way to heat the sphere of air, so the metal sphere with the air inside it, is to drop the sphere into a water bath or a kettle. So if I take the sphere and I drop it down into here, so it's completely submerged in the water, when I switch the kettle on, that will obviously start to heat the water, and that will also heat the sphere with the fixed volume of air in there. The only other thing I need to do is obviously to measure the temperature of the water, so I'm going to add a digital thermometer there to that as well. And then when I switch on, the temperature of the kettle will increase. I need to allow a little bit of time for each reading before I take the reading, so that the air inside the metal sphere, so the air inside this metal sphere, is at the same temperature as the water, so the temperature I'm taking is an accurate representation of the temperature of the air inside the sphere. And the pressure here, you can see there's already a pressure because there's atmospheric pressure, so you can see there's a reading on the dial already, so we can record the pressure straight from the gauge, and we can record the temperature as well. In fact, I think the easiest way to do this experiment is to heat the kettle up to boiling and allow it to rest for a minute, and then just allow the water to cool naturally and record the temperature and the pressure as it cools down. And in that way, hopefully the air temperature inside the bulb is the same as the water temperature. So the thermometer is reading just going up above 90, so it's nearly 92 degrees, 93 degrees. So we're close to boiling, so I'm going to let it get to boiling. I'm going to leave it running for about a couple of minutes. So hopefully the air is at 100 degrees as well as the water, and then I can record the pressure. So I'm now ready to take my first result, and I'm recording the temperature as 98 degrees. So I'm going to record that down here as 98 degrees, and the pressure, I'm reading off the red dial, is 1.1. 1.145. So I'm going to record the pressure and the temperature on this sheet as it cools down. So we're now, the temperature is down to 50 degrees, so the kettle is gradually cooling down, and I've been recording the pressures from the gauge as the pressure has dropped. And what we'll be able to do once we've finished is plot these points on a graph to analyze the results. Okay, so we're almost ready to take the last result. So these are the results we've taken so far. This was the initial one before I started warming the water up. That's why that one's complete. So I'm just waiting for 30 degrees, which I can take now. So at 30 degrees, the reading on the pressure gauge is 1.020. Okay, 1.020. So I now have all my results. Now, as I mentioned, what we've got here is the pressure of the air molecules inside the metal sphere, and this is the temperature of the air molecules. And it's quite clear that as the temperature increases, the pressure increases, and that is because the air particles are moving faster, so they will collide with the container walls with more force, but also more often because they're going faster.